The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dan DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. Today, Thursday, April 14th, 2022. There has been only minor change in the volcano, no increased threat to people, but what we have seen is a new breakout from the west vent that's shown on screen right here. So we'll recap that. Overall, the activity has kind of come back to normal eruption rates, so we'll recap that part of it as well and look at some of the time-lapse changes on the volcano's surface here over the past week. So we're taking questions as usual. Let Dane know if you have something that we can't answer in the chat. If you have any issues with our audio or with our video, as usual, let him know. And otherwise, we will get right into it here. All right, so what I'm showing you guys here is just a little teaser just for what we're going to get at a little bit later in our update. This surge that appears to be coming from the southern part of the west vent. And what I've done here is I've taken out all the daylight images, so we're looking at a gap of the daytime here, but just nighttime, just to make it pretty so you guys can really see maybe the theme here for this week. So having teased that, let's move on here to show you guys a recently released aerial thermal map of the crater. And in this crater, the red colors are warmer and the blue ones are cooler. So what you're looking at above is this is the main surface of the active lava lake down here. Let's see if I can get down here. An arrow. There. That's that main active surface with the little pit detached to the southeast there. And we've had these ooze-up flows that have been pretty large. This is one up here in this northwest corner. Calling this kind of cat ear appearance for a while. Well, today it looks a little bit more like an owl to me, but take whatever you like out of it there. So ooze-up flows here along the perimeter. They can be pretty large, larger than the active surface of the lake, which is down to about 2% of this entire area right now. This was taken April 6th, so just a little bit over a week ago. And I wanted to start off with this big picture view of it, just to not get too focused on these little changes right here in this west vent complex, but more in a big picture of what's happening overall. And that's that we have had ooze-up flows coming up, and they've slowed down a little bit, but we've had them come back here in the last couple of days, and perhaps they're continuing at a lower rate here. So what I want to show you guys is a view from the B1 camera on the east, and looking back across the lava lake. Active lava lake area is back over here in the far background, so that's what you guys will see over here, as well as that little breakout. But focus more on what's happening across the rest of the crater here, and that's going to be all these ooze-up flows that occur along the perimeters there, and here, down here, and over here as well, right along this edge. So I've made it the last 2 weeks, so I'll play it for you guys here and see some of these. Actually, what I'm showing you first of all is just the last few days here. This most recent ooze-up coming up out of the south here. I'm sorry, this is the east, and then here the southeast. Here, so it's the last few days. And what I would do now is put it in the context of the last 2 weeks. So here's the last 2 weeks. See some ooze-up flows all along the perimeter. Lots of activity along the crater floor, as we covered last week. It seemed like that might have related to an increase in eruption rates that we documented through Usgs data. But with newly released data that came out this past week, we can now say that the rate is back down to its normal background trend, right? So we'll go into detail of that here in a little bit. But overall, you can see a lot more darkness during that interim there, and then a few of these flows here in the last couple of days on this eastern part, and a little bit on the northern part here as well. So ooze-up flows are still continuing, not as frequent as they were last week, with a big gap. So you kind of see that visual element of the slowdown of what's happened recently, right? It's still active, but it's back to its normal shenanigans there. Okay, zooming out from that thermal map, we have this larger satellite view. Here's a whole main caldera all the way around, right? With Kahuna area over here. The Kinakakoi overlook over here that we've pointed out from before. Upina'i Pali, Waldron's Ledge over here, Volcano House over here, Steaming Vents, Wahine Kapu. So all these areas all around the main caldera, and then deep in that inner crater pit is where lava's been building up. And so it's been filling a good amount of this lower floor, and a lot is happening within that pit and that cauldron in there, but it's still contained within that inner pit, and beyond that there's another pit, and beyond that there's another pit. So it's really well contained and safe for everyone, and there's no signs of this magma going anywhere else. It's still just filling in. And really, it's been a time for great viewing in the volcano as usual here. But to kind of stay big picture for a little bit longer here, here's a most recent map put out by the USGS, April 8th, and showing that cat-like, owl-like shape right there, with that original stint of the crust before this eruption, and you can see how it's expanded towards the edges. And so largely now we have this older piece of crust as what's been rising buoyantly, and lava's been oozing out on the outside of that for the most part, overflowing and filling in all these low-lying areas. So the shape is no huge surprise. We've been following that for a while, but I wanted to zoom in here on these statistics that are a little bit more precise. Once again, when we put out these maps, they give us another significant digit here. So we actually are up in volume to 66.4 million cubic meters, 17.5 billion gallons, now covering 219 acres or 89 hectares, right? The rise has been revised 99 meters. I think one of our last maps might have put it slightly over 100, so we're actually at 99 according to this. And that puts it at 840 above sea level right there. Okay, so we can take these values, especially this one right over here, and we can then put it into our figures. And so we're actually at 66.5-ish, right? So we've only gone up one. Zoom in into this in the right corner over here. Right? We've only gone up about 1 million cubic meters. But you can see that the trend over the interval of time is a little bit less steep than it was previously. So this is this idea that we had kind of long-term trend and a little extra juice for a while, and then we're kind of back to that regular trend, something like that, right? As our working paradigm now. You can see that this blue line down here was the last eruption that began this whole summit phase of activity. That didn't last quite as long, so this is really just showing us that eruption now has gone on good amount longer, right? Over a month longer here than the last one. It's way out, way exceeded the volume it put out as well. Did a little bit of those big picture things last update. So as far as the rates, I'll zoom in here to the bottom right once again, a little more. And what you can see is that we had been on this long-term 432, somewhere in that ballpark, very roughly cubic meters per second diffusion rate. And it seemed like we had jumped up, maybe doubled it to around 6, and then we're now back down to 3.2-ish, something like that. So it seems like we're really kind of continuing that longer-term trend with the little extra bump we got right in there. So kind of back to normal on that front, which if we look here at this long-term summit lava depth plot, right? This is from the beginning of the eruption back in the very end of September 2021 until now. We had that initial quick rise that occurs here. I'm gonna have to zoom into this some more by the looks of it. Yeah. So that initial quick rise that flooded that former crusted crater floor, and then a slow rise of that crater floor with some gaps in data and some adjustments for where the thing was pointing. And then we started seeing, it seemed like the lava lake had formed that inner active area that was filling and draining with deflation-inflation cycles. And it seemed like the laser then was measuring that cycle, right? Something about the shifting features on the landscape, right? Actually putting what was in the path of the laser before as perhaps a rising bank of the lake might have been the actual lake surface itself. And then later it seems, once again, after another gap, becomes perhaps that bank or something on that crust once again as well. So I wanted to show this one as a big picture, kind of shows the overall pattern, right? It's a little bit noisier with the deflation-inflation signal in here, but you can kind of generally see the long-term pattern of coming up. And it seems like it might get a little bit steeper and then flatter out again, right? So that's once again that little extra bump we got visible in a little bit of this depth plot once I explain away all the extra complexity here. So looking a little more closely, this is the last week of lava depth right here. So actually that little bump was before that, because at the start of the week, last week, following our last update, we had actually a lower lava level. So the lava level on the lava depth on the more stable bank was essentially fairly steady right there. And then later, following the end of that deflation cycle, when it starts inflating again, lava bursts out at the surface. It's not clear exactly when, but we had been seeing a lag before that. So perhaps somewhere in here, it might actually hit the surface, fill that upper active lake area, and then the banks and the other area start filling it and start showing that rise afterwards. If I had to interpolate this time frame right in here, that's what I would expect to see. So that's the biggest signal, is that last week right there. So this thing's steady. We've had a couple other little V-shaped signals in here. This is looking to me similar to that gas pistoning signal we've discussed in the past. Essentially, it's just a smaller, less obstructive transient here that's got to do with the outgassing of the volcano. So without going into more detail, everything is kind of normal there. And what you can see is it's maintained this fairly even, steady pressure ever since late last week there. So if I come down to the last month, to give us a little more perspective, the very beginning, when this instrument comes back online, this steep part right in here, that's that extra juice, the extra amount of extra magma, extra fusion rate somewhere in there, going back to who knows exactly. You can't see from here. You can see it's still coming up, and there's our deflation event, corresponds right in here, that thing right there. Inflation, and then it's come back to its normal rise once again there. So interesting that during this little extra rise in the lava level is when we have this lack of big deflation inflation events. right? And we saw some of these other signals in here, and we thought something else might be going on top of it, on top of the background signal. And it seems like whatever it was is a signal of that extra magma coming into the system here and then passing through. And I'm not sure this is all of it necessarily, but this is just what we can see right here and what looks the clearest. So if I was investigating, I would be looking in this chunk of time right in here, especially, right? Possibly right in here. So whatever it was, it seems like it's over. We're back to our old pattern. Lava levels are rising and falling once again. Here, a big inflation cycle. The lava level dropped and came up again, didn't disappear. So viewing has been good still. SO2 has been, you can see, reported more frequently here. So we can see the pattern of even during that time when we had what appeared to be this deflationary signal, right? The gas level was still high. We're probably still in a tail end of that, effects of that, whatever transient process was happening there. And then once again, inflation, dropping back down to, I think it was 1,300 tons per day. Not quite as low as we've seen before, not in the hundreds, but quite a bit lower than what we see days before it and the days since then. Right, so that pattern is also holding once again. Right, the actual fixed station at Sand Hill, you can see, is showing values that still are peaking fairly high in that area. That's in a closed area of the national park. 9 ppm of SO2 here. For downwind locations, we'll look at the SO2 VOG forecast map here shortly. But just wanted to point out overall one more time when I just came across this as part of one of the articles Usgs put out this week. These are shield volcanoes and lava fields, a whole bunch of the different hazards that can occur on these volcanoes, right? And so overall, all kinds of things can happen. You know, lava flows themselves, ocean entry, the lays, the tubes, breakouts, all this stuff. And we don't have any of that because everything is contained within that crater, as we've been describing. So that's why it's such an ideal time to visit and see and all of that. What we do have is perhaps diffuse ash and that gas, more gas than ash now, and then we get the VOG, right? That kind of associated with prevailing wind. So that's what the aspect of the hazard that we have for this volcano now. Fairly minor for most people. There are some areas that get it worse. Here is the weather.hawaii.edu VOG mapping project. Here you can see the source of the volcano and the emission rates at about 3,000 tons per day, combined with the forecast winds here, predicting the VOG distribution across the island. So still in the southwest is usually who mostly gets it. Still getting some caught up on the Kona side, but you can see it seems to be coming and going. So hopefully not sticking around too long for anyone over there. So the further south you go, the more likely that is to happen. Still, overall, not too bad. 3,000 tons per day is, not nothing for sure. It's a big amount. It's not anywhere near the highs that we saw at the beginning of the eruption. And it's fairly close to the long-term rates that we saw during Open Lava Lake from 2008 to 18 that lasted years and years and years and years. So that value may be something that we might have to get used to, perhaps, if it stays open. So certainly there is an impact, but it's not as far as lava flows, and it's just the gas blowing across. And of course, if you're sensitive, then it's extra important to pay attention to that. In a national park, all the visitation areas are still in a green, have been in a green every time we've checked. Really all eruption for the most part. We're getting strong winds from the northeast, so all this gas plume is blowing in this direction over here to the southwest. You can see that's why everything is in the clear. But there are some times in the morning when you can have weak winds or some extra rain causing extra water to be available, so you get sulfurous steam or some other things like that coming into the area. So it can vary locally, but overall it's been pretty good. And of course, anyone going to visit the national park and see the views from those overlooks should be checking the park website for all of their alerts and notices and all of that. All right, so here is our large pit. Lava Lake is deep inside of it. We've pointed out these areas before as far as viewing. Wikahuna, still active. On the eastern viewpoints, we're once again going to focus just on Kanakako'i today. And once again, we're going to feature our friends Two Pineapples, who submitted this video to us of something they shot this morning. And I've just clipped out a few seconds of it here to share with you guys. So zooming in on that main area of the vent. This is actually not that west vent pond that's just further to the east, but one of the other cones of the west vent complex that's you can see just oozing up and feeding a river of lava that's going to pour back into that main lake. So let it scroll through here. Right, here's our wider view. And there's that vent. And here's our little river of lava coming into the main active pond. Down over here we see some bubbling at the far end of this pit. That's that detached little pit over here. That lava falls has sometimes been visible in this zone over here. Now I've sped it up and time-lapsed it, so you can essentially see more of the motion coming through. In the back area back over here, this is that new large lava flow that's come out of that southern west vent complex area right in there. So pretty cool. I'll play that time-lapse segment once again here for you guys. Coming up, so at this point in time, you don't really see so much of the lava coming out of the vent, which is more over here, and that was the source of this big flow. But it seems like it's ponded and it seems to be overturning, and there's still a little bit of movement, and it might be more on the backside, so maybe not directly visible always, but a lot of changes in this entire west vent complex right here. Mahalo you guys for sharing this video with us and for doing your live streams. Lots of people are enjoying that. On streams here, like the one we had. So I did want to just come back into this stream just for a second here, because I wanted to once again give you guys a context, right? So this is another piece of that stream, and we're gonna zoom it out here from this main area. I think put it in the right section. Bump it forward here. There it is. Right, so zooming it out, get a wider view of that whole caldera. This morning you can see pretty steamy as it's getting light there. Foggy, so maybe some rain coming. So there's always that kind of weather, but even still, you're looking down into the pit and you can often see that, right? So you saw that view there, Mauna Loa there, so leave it at that. Not greatest live, right? So coming into our S1 camera, this is the one we've often used as a proxy for what you see over from that southern Kīlauea overlook. And this is for the last week. Play this, loop it here. And there's a few things to notice. Look at the big picture first. You still see some glowing vents east of that main island, central island over here. There's a little bit of ooze-ups up here on the top, and you do see this big breakout occurring mostly off a screen here to the left. So zooming it in here, first we can look at that main lake area right here. So we can see looking at during the daytime images, the height of this dark band at the rim of the crater. Estimate a little bit of the relative level of how full it is, right? So you see not as full right there, and then filling in lava falls coming into this pit in the foreground, continuing, and then eventually it gets a little bit extra full, overtops that little levee, and it floods that area, and now it's been level ever since, with a couple overflows coming off of the edge of this thing. There. Not a whole lot of change visible from this angle of this upper complex. You can see seems like fluctuations, whether crustal overturning or variations of level of the lake. You do see some flow coming out of there, but we'll look at that from a different angle. It'll be easier to see. And over here is that northernmost part of that west vent complex. That's what we just saw on the video submitted by Lou and Anna Pineapples here, where that starts reactivating and then puts the flow down right over there into that main active pond. And so that's what we're seeing from the overlook, except that this camera is actually cropped off here. We can't see off to the side, which you could see as I showed you guys in the video. You can't see really. You can see the vent is right on the edge right over here, and it's putting out big flows both to the south and to the north, right, all along the southwest edge of the crater here. And I think we're really, let's see if just to check in on it here, let's refresh this. And as we come into spring here, it's not quite dark at the time of our update. I'm not really seeing the red in in the image here, but it looks like everything is still full and flowing. We'll look at the V1 camera for that reverse angle. And this is the last week once again as well. Wait, this is... We'll move to the KW camera. That's this one, right? So okay, so what we're looking at now is that wider KW camera. This is the one that has a view of everything that's happening in the entire caldera, and I've cropped it a bit here and zoomed it in for you guys to see. So this is over the whole last week. So you can see that early on, a little bit of ooze up on the north side over here. We later get some ooze ups on this back eastern side over here that we showed you guys early on with that B1 camera view. And over here on this right side, this is that southern breakout from that western vent complex there. Here, I'll zoom it in a bit, see it a little bit more easily. Now we're showing this at a pretty fast speed here for the whole last week. So we will also slow down here in a second for you guys. All right, let's first show you guys the thermal view. So that very similar view is the F1 camera. It is also cropped off. You can see at the beginning of that last week that this ooze up on the north left side of the screen here is truncated by the edge of the camera. And when this breakout happens, it's going to be off of this right side of the camera here as well. So a little bit challenging to see everything happening across the whole caldera today. But you can see, there it is, some flows coming along the right edge this way and going further off in that direction as well. So you do get a couple of little overflows from this west pond vent. You get a little bit of an extra lava flow coming out of this vent before this main breakout in the last few days over here. So let's once again zoom into it temporarily, and so now we'll just loop just that that recent breakout from that southern part of the west vent here. One thing I thought was interesting is just looking at the timing of this. I'm just going to loop at the beginning here. This goes off first, then we see this go, and we see this surge forward kind of last at the active lake. It spills out a little flow that goes off in this direction. And so interesting that it's not actually feeling the pressure everywhere at the same time. There are some variations, and so interesting to think about the pathways and the obstructions that exist to get the lava into different areas of the crater floor here. So I'm going to zoom way into this corner over here. That's what we got. And right over there, you can see the edge of that vent, and it's putting out flows off the screen for the most part, but you can see the vent itself a little bit right over there too. And later on, this is the vent that bursts out and puts that flow that we saw from the other direction. So there it is. The details of what we can and can't see, and of course, interesting to see that all from the overlook as well from a different angle too. Okay, so here's zoomed in on that surge, a little bit slower. Nighttime and daytime. You see in the daytime just a silvery appearance, a lot of fume in a way you can't really see as easily. But this gives you a little bit of the fuller picture that's getting covered by that F1 camera view as well. I should mention that F1 did go down a couple of days there, so there's a little bit of a gap between offline and bad frames there. So here it is in its full composition, viewed from that wide-angle camera up in the Western Rim KW camera. That entire breakout here. We've seen things like this before, but interesting once again, just like last week, the relative size of this thing, seems bigger than the actual active lake area, and partly it's because this thing is still shrinking from the edges, kind of closing up, right? And might be hard to see that unless I pull it back here and really wiggle it. Let's see if I can zoom it in. Maybe you can see a little bit that the edges are coming in as it rises up a little bit. It's hard to tell exactly, but it's kind of around here and around in here where I'm looking. All right, so overall, it's still filling from below into that crust and bursting forth, and that's essentially what caused this west vent outbreak. Not enough lava seems to be getting out and circulating through this active open area right over here to the point where it's oozing out all around the crater floor and including close to this west vent over here. It's essentially that southern edge of it, but it's almost far enough that it's becoming its own ooze of flow as well. So kind in that transition zone right in there. So a couple last things. This one is going to be our V1. Here it is finally. I had to order earlier. So let's play the V1. And we can, since we've been talking about the vents, let's focus over here on events in the top right. You can see the flow off in this upper corner, and we see some of the spatter and smaller flows that ooze out vent here, especially at the end where you can really see some of that low fountaining occurring. Bursts up here and then flows out that way and back this way both. Looking at the finer details here, there it is. See the cone building up. I'll move it over to the pit area. We don't really see a whole lot of changes in the spillway. A little bit extra glow. Glow is changing locations a little bit over the course of the week in the spillway. Still putting out a lot of steam and volcanic gas as well. And we can see within the pit itself, lava levels rising and falling and rising and falling. But perhaps most interesting is that this pit continues to grow and expand. At the very beginning of the sequence here, you see this big chunk falls in, to the point where you can actually see that lower lava lake level and its connection all the way across into that spillway, even at that low level, which is interesting to see. We've been talking about that for a while, and it came into view here, right there. And ever since then, we've just seen the variation, right? So a lot of this upper area around here is where we had that little spatter tephra and spatter cones building, and it seems like some of those have partly fallen back in. It's hard to tell from this resolution of the camera here. That's some of the interesting minor changes around the vent, West Pond vent area itself. Here's a view taken April 6th in USGS through their rangefinder, or some kind of telescope here, and looking at a similar area. You can see it's all crusted over there and there with a couple of holes that are glowing and probably putting out spatter. And then this is that big spatter rampart. Spatter, not exactly a rampart, it's not really a fissure, so it's essentially like a cone here, spatter mound of some kind. This chunk of land seems to be one of the part of what fell in, which would make sense if it's all brittle and loose as well, right? So minor changes back through there. This is the only photo we have from the USGS this week besides our new maps. We appreciate those. And let's give this page a reload and see what the V1 is doing as we're live here right now. It looks like it's being a little blurry here, right? So, but it looks like it's actually, to me, did they zoom this out, Dane? What's going on here? Why am I confused? See what I'm saying here?
This is the V1?
Yeah, this is the
that we're looking at?
The V1 live.
Let me pull up the record on it real quick.
Yeah, so it looks like to me like our view is slightly different. Let's go back to this wide view, yeah. We're kind of
it completely changes at it looks like they changed it at 3 p.m. between 1 and 3.
Here's our last 24-hour animation. Expect the camera to shift here, zoom out at least, right? Because we really couldn't see anything happening in the eastern segment, and there it is. There's the reset.
Yep, the next week's time lapse will look a lot different.
Yeah. So, all right, little nuance in the view one here. Became obvious on that reload there, and here's a KW camera, and let's just give that one a reload. Okay, now we have shade across much of the caldera floor, but really no huge brightness anywhere except that main active lake area right in there. Still looking fairly normal there. So F1 just to round it out, as we can't necessarily see with a light as easily, right? Their main active lake. There's an ooze up visible over here, and still some heat in that overturning area, but it looks like the vent itself is not actually putting out lava that we can tell right now. So it seems like that southern breakout may be winding down. We've seen in the past that they can activate, activate, pause, reactivate, pause, reactivate, and so on and so forth. So let's just wait and see what happens over there. So we'll have a few last signals to cover before we wrap it up here and do some questions. Here is our long-term GPS pattern Still holding its similar trend, and not really worth going into any more detail here. Same with the 1 year Pawoo GPS, some small term variations, but once again, nothing worth going into right there. Earthquakes over the last year were still pretty normal within that recent pattern. Nothing has changed. In the last month, regular up and down, random variations, but overall fairly average across. Over the last week, nothing really super noteworthy. We have a few earthquakes in that summit crater area. A few of these deeper ones that are in blue. The Hala earthquakes in blue are still deep over there with that closer over to the side. So in cross section, Hala is actually looking, it's doing its normal thing. Maybe not going off quite as much as it has in some recent weeks. So, but still, that's just a relative term. It is going off. It's just, this has been going off a lot. And recently, not as much. Not as big as earthquakes, perhaps, might be a better way to see it. And still some continued activity down here underneath the main area of Kilauea, right? That feeder source potential right there. Everything else is south flank on that map. Okay, for the last month, a little bit more data on the map. So a little more clear what the patterns are, but it's all the same patterns exactly. No real temporal change here so much. So those are the earthquakes. Here's our earthquake map. Looks like we just had one pop up here, 1.7. Came in 5 minutes ago. 2.3 kilometers down, regular south flank earthquakes. Otherwise, not a whole lot going on this map here. We have still some activity in Mauna Loa, nothing really to speak of. Still some Pahala, nothing much to speak of. Here's our largest magnitudes for the last week. It's 2.8, 2.7, and below that everything is 2.5. So really, it's been pretty quiet in the earthquake front. Couple last things. This week's Volcano Watch. Geologic whodunit. Ash down in the Pahala region from Mauna Loa or from Kilauea. And here written by postdoc researcher Julie Chang. And looking at some of that ash, interbedded ash areas over there. And that's an area that is exposed to both downwind zones of Mauna Loa and Kilauea. And they're doing a study there to figure out exactly what came from where, to try to figure out the intervals of explosions and all of that for both volcanoes. And so looking at the details of that, I won't go any further than that for you guys here. All note is that they did find in the ash over in that Pahala region. Where is it here? Tephuras from both Kanakakoi ash, circa 1500 to 1820 CE, and the Kulano Kuaiki tephra from earlier 400 to 1000 CE, both from Kilauea appear to be present, as well as at least one tephra layer from Mauna Loa. So that's some preliminary results that are being shared in today's Volcano Watch. There's other USGS output this week as well. One is as public comments sought for environmental pre-assessment consultation. This is for the main office. I know we've talked in the past about the office within a national park. This is not that. This is down in Hilo as part of the University of Hawaii Hilo campus. And they're sharing this with the Pacific Island Ecosystem Research Center, Pierce. I'm not sure if that's how you say it. That's how it looks. Which is ecology and biology and other USGS disciplines as well. Let's go. That's the public comments, and so this is essentially a very, very short notice, but you can look at this on the USGS site too. If you believe that you're near that area, an intersection of Komohana Street and Noella Road near UH Hilo campus, that you may write to them and be included and process from early. And so there is that going on. And finally, there is volcanoes and USGS Science, just the facts story published on the website as well here too. And so this is essentially, I've looked at it as kind of like a narrative table of contents for lots of different things USGS has to offer here. It comes from our communications and publishing team apparently here. But to kind of highlight what kind of links exist in this guide that I'm not sure we have posted, but we will soon if we haven't yet. Links to the Volcano Hazards Program, Volcano Science Center up in here. Overview of volcanoes from USGS, General hazards with every eruption, whether they're stratovolcanoes or shield volcanoes, like that image I showed you guys earlier was from that fact sheet. Looking at statistics of volcanoes across the whole country. Right? The US is one of the most active countries. Since 1980, there have been 120 eruptions and 52 episodes of notable volcanic unrest at 44 volcanoes. Of the volcanoes that exist, there's 161 in this network. 86 in Alaska, 19 Northern Marianas, 14 in Oregon, winning the mainland here. California, second on the mainland, 12. 7 in Washington, and here comes Hawaii with 5, and we'll cut it off there. And of those 161, you can see 18 at very high, 39 at high, 49 at moderate, and the rest at low, very low. Of course, as we've discussed before, and since the images up here, it's a combination of naturally occurring hazards, the exposure of infrastructure, people, property, including aviation, and this intersection of the exposure and the hazards that really makes it a threat, right? So even though we have hazards occurring right now, they're so far from any people or property or infrastructure that we don't have any threat. What's happening at present here? So frequently asked questions, everything from monitoring to how you become a volcanologist. There's a glossary that has all the terms like tephra, whatever else linked in here as well. I show things like tephra and leilani. Threat categories plotted across here. You can see how many are in Alaska. Evolution chain. Evolution. Disaster assistance program. That's funded by USAID Humanitarian Assistance, which is like a task force team that flies to other volcanoes across the world. Global volcanism program linked in here. Monitoring. Topics. Monitoring graphics, all the different tools in the toolkit of volcano monitoring, whether it's in a gas, satellite, on the ground, campaign with people, alert levels, updates, set up for notifications, all these different links, right? Showing you guys different aspects of electronics labs that they have, what it means to be a volcanologist. Someone who studies burning mountains, or other teaser. If you don't know more about that, you can follow some of these links. What volcanologists do, living with volcanoes in your backyard, fact sheets. You can see lots of links and lots of things in this article here. Preparedness resources by region, so you can find all the different hazard maps for all different parts of the country with different volcanoes. Fact sheets about St. Helens. So I think I've gotten to the end of it here, but quite a lot going on. I wanted to make sure that everyone saw that this does exist, and it's like I said, perhaps a living narrated table of contents of different aspects of what there is from the USGS online, right? Kind of a sampling of all the different things put out. So once again, mahalo to the USGS for all that data, everything we showed you guys as far as the webcam images. We've animated the webcams ourselves. Mahalo Dane, Bob Martin, you guys for collecting the images. Putting the animations together. USGS providing the webcams, providing all that monitoring data, all the reports. To our viewers, including 2 Pineapples, for submitting those videos, and wherever else we want to mention, Dane, I'll pass it over to you.
Yeah, we do have a couple donations that came through. Want to acknowledge them in the super chats. First was Tim, who just says mahalo with a $50 super chat. Thank you, Tim. Sean with a $5 super chat, no comment attached.
Mahalo, Sean.
And Chris with a $10 super chat and a level up emote attached. And appreciate all you guys. Appreciate the support. If you want to support what we do, the best way to do that is like, subscribe, share. Commenting after the video really helps a lot. I know people hear this stuff all the time on YouTube, but it really does drive the algorithm. So we appreciate everybody that does that. If you are so inclined to make monetary donations, we really appreciate that. We also take those on hawaiitracker.com/support. That's Hawaii Tracker is where we deposit all of our content. It's in a chronological order, so it's easy to find right there for you. We also operate the Hawaii Tracker Facebook group, so if you're not a part of that, go ahead and check that out on Facebook. And we have one sponsor we want to recognize today as well. That would be Kilauea's Bar and Grill, longtime supporter. They got 2 locations, one in the part of Pahoa, and the other one is new in Orchid Land. They have 2 unique menus. The Pahoa location isn't open as much as it used to, but that Orchid Land place is open every night. Indoor, outdoor dining, takeout orders, all that stuff. They got unique twists on some traditional dishes, add a little bit of local flair to them. So definitely check out Kilauea's Bar and Grill, and we appreciate them as longtime supporters. With that, I think we can get into some questions. We don't really have that many today. And if anybody wants to get in some more questions, I'll go back through the chat before we end. Mad Hacker asks, is the eruption rate still as high as it was last week?
All right, let's see. Let's bring the graph up. Here it is. The eruption rate is not still as high as it was, although we have a little bit of a lag between the USGS reporting the data and we actually having a report. So it's actually between April 6th and March 30th, so it's that previous week, right? So last week was a low rate. It was the 2 weeks before that, the last 2 weeks of March, that were that higher rate, apparently, according to the maps that USGS put out. Yeah, mahalo for that, Mad Hacker.
Yep, and Mad Hacker also just made a $20 donation or a super chat and a smiley face emote. So appreciate that. I hope that answers your question. We have one more here from Sharon. It says, silly question: does the level the level of the lava, the elevation of Kilauea, compared to sea level, have any changes on the dynamics of it filling?
Well, you would imagine that in the grand scheme of things, it should have some, because there's just more head, right? More material, volume, and mass that's all above what's filling it from below, but we know it's filling it from below and not from above.
Right.
So yeah, but it's also kind of flaring out, and that relative difference between that filling crater compared to where it's coming from down within the volcano at a greater depth may not be as great as we imagine. Right? It could be significant at times, but it could also not be that significant. So the other interesting thing is that it seems like that original crust of the lava lake is somewhat buoyant, right? And so it's still kind of floating up,
right? And
not necessarily pushing down so much as it is just kind of rising up, and then lava is oozing up along the sides, right? So it's not like there's an extra heavy cap of solid stuff above it that's pushing down. The stuff that's above it, it's solid, is kind of floaty, and it's more the mass of what's that giant liquid pool within the crater that's kind of not visible mostly to us, because we're seeing it all, just the upper crust of it. So yeah, I think it must change a little bit for sure. How significant that is probably depends on how deep down a magma is coming from, and the actual pathways, and the pressure gradients, and all kinds of things like that. To the point where I think that's probably more important than a smaller change in elevation that's had. Although elevation change is getting significant between the last eruption and this one now.
Yep, moving on up.
It's getting up there. And yeah, one
Kenny,
note on eruption rates, and we did some projections in the last couple of weeks, and our projections included both like a lower eruption rate and a higher eruption rate. So it seems like we got to revert to that lower eruption rate once again, right? And that's kind of why I did that. It seemed like that could have been a short-lived thing, and we're still looking at years, right? Like 6 years to get into the caldera, or by the end of the year, possibly onto that next little ledge that we're still going to be a long time.
Right. Kenny asks about the tilt that we've been seeing recently. He has missed it earlier, but why are the DI cycles seem flatter, so to speak? If we did not get that big one, it would be pretty flat, flattish graph. Maybe we could bring up the tilt again.
Yeah, here it is. Mahalo for the question, as always, Kenny. Mahalo for joining us, one of our loyal viewers here and commenters. Yep. Do what that guy does. So here's what he's talking about. This is the last month here, so it gives us enough you to really see that one big deflation, inflation, and this might be with this kind of flatter part that he's talking about there and there, right? So yeah, it's interesting. This might be what we're considering might be connected to that extra the extra rate of lava coming up, right? Because we saw we're talking about the last 2 weeks, right? The whole thing filling in. So it actually was occurring through here as well through some of the ice cycles. But whatever it was, is whatever dynamic is occurring with more magma coming in for a short time, possibly might be what caused it to be flatter and more stable here, right? So we'll see what the pattern is. I mean, it hasn't been quite long enough to see if we're going to have more than this one, or how frequent they're going to be, or how regular they'll be, because we've had them in the past be fairly regular too.
There is that. There's one little weird thing to me is the failed DIs, or what I would call the failed DIs, that they didn't complete the entire cycle. You get the deflation, you get the inflation, inversion, and then it just doesn't quite finish it. Right about after that big blip, it's interesting to me, almost like it on about the 10th, maybe the 11th, tried to go into a DI, something over you can't see the DI there other than where it should be, type of thing. You should be like, that would fit a DI profile, except there's something else there that's screwing with it.
Yeah, I mean that
that's
looks
almost
to
what it
me
looks like to me.
more like that gas pistoning signal that we've seen.
Okay, yeah.
It's interesting that you know we have seen that more frequently at times in the past, and then less so where we've seen more of just a larger DIs instead of that. And now we're seeing not exactly the same as before, but we are seeing the one large DI with these few V shape. You know, maybe we can call it a U shape, like a large one, and these be the V shape ones, right? But still, very very short lived ones that seem to be more associated with we typically see gas pistoning kind of effects. And there is this, and I don't know if I can find it. There's a section in professional paper that talks about this from the last 10 years of eruption, but I'm not sure. But
yeah, that'd probably take a little bit to pull out. Definitely interesting the changes that we've seen on the tilt and over the past couple weeks and months. I remember there was periods where it was every other day tilt DI cycle. Pretty consistent too. And now we're in a period where not so many.
Yeah.
Or not so many of the ones that we're used to seeing. Those U-shaped, clearly pronounced DI cycles with a clear end, clear beginning.
Right.
Kenny asked about making a special video on the paper. I think we've mentioned the paper a lot on the air, and it's one of those papers that there's a lot to go through too. So it'd be like a multi-part series, if anything.
Yeah. There are some papers that we haven't done full videos on for sure.
Oh yeah, for sure. But they basically get mixed into the other content as we go.
Yeah, I try to kind of not dump too much at once, and I know some of you guys have no issue with staying and watching us if we go for an hour and a half or 2 hours, but overall, seems like aim for shorter than that if there's not anything major going on, you know.
Right. We're right about an hour now. About our normal runtime.
Can't find my graph to get it to.
That's all right.
When we run these live, sometimes I'm trying to open those large files.
Yeah.
I run everything off my laptop here. So. All right. If I can find it, I'll pull it up for one of the next times.
All right, sounds good.
Last second. Find something to bring it up, Kenny. Sure. Yeah. For now, just take my word for it that looks like that signal we've seen for gas pistoning events.
All right. Well, I think that does it for the questions. Oh, look, I didn't see any more on the YouTube. Check the Facebook. Yep. All right. Well, I think that does it for me for today. Appreciate everybody that turned out. We will be back at our normal time next Thursday at 5 p.m. Hawaii Standard Time. Unless anything comes up, then we will go live. But right now, I'm not really expecting it. All right. I'll pass back to you, Phil.
Hey, Dane. I'm still was looking to see if I can find it at the last second, but no. Next time, you guys. So, yeah, thanks again for joining us. So next week, as Dane said, for Hawaii Tracker, he's Dane DuPont. I'm Philip Ong. Mahalo and aloha, everyone. Like, share, and subscribe.